Hello students, good morning. Good morning to everyone. I hope you are studying well. Now because JEE has declared its date, so I hope you have scheduled your academics accordingly and you are planning to crack the examination. Okay. So if you have given the January JEE means, okay, or any state level exam or BID-SAT, you will understand that this is a very important chapter. Okay, this is not there in JEE Advanced, but for JEE Means point of view, this is a very important chapter. Now in this year's paper, I am talking about this January 2020 JEE Means paper, there were at least one question in all the papers conducted in all the sessions. So you can safely bet on this chapter that there will be one question on this chapter. Okay, so in chemistry in every life, environmental chemistry, these two topics are the topics which are often neglected by the students. Okay, so all the hard work that you had done for doing the important topics, okay, or for doing the chapters that consist of reactions, mechanism, even high level problem solving would go in vain if you are not doing this chapter particularly well. Because I have seen many students who were very good in their fundamentals, who have done a lot of high level problem solving, but they missed out on reading NCERT and doing the theoretical portion. So eventually they lost in JEE Means, they lost 20-24 marks in all the papers in physics, chemistry as well as maths. So eventually they landed up a score of somewhere close to 250, okay, 250, 230, and they were expected to get more than 270. So obviously the main reason was they didn't focus on these chapters, okay, and there were many students who were not good in concepts, who were not that much strong in all the chapters, but they had done their homework well, they had read the NCERT well, and surprisingly they scored more than 200. So if you can see, there is a certain strategy to crack JEE Means. It is not difficult at all to crack JEE Means with a good marks. Only thing is needed is a quick revision of NCERT and memorizing the important parts of NCERT. So I have already told you we have completed coordination chemistry. I hope you have completed your coordination chemistry, okay, and hope you have done the previous year solving. Just solve all the previous year questions of JEE Means as well as advanced. It will give you an idea what kind of questions are asked. Okay, if you see there are a lot of theoretical questions and you need to go and read some theoretical data, so you can do that as well. Okay. So in chemistry in every life, there are few segments that is very important and questions can come on their structures. Okay. So one thing which you have to understand is this preparation is not all about the conceptual power that you have. सिर्फ concept से बात नहीं बनेगी. You have to understand that there will be some theoretical question in chemistry. Out of 25 questions, you can expect at least 7 to 8 questions as the theoretical question. And 7-8 questions, theoretical questions is a very big number. Okay, because if you leave them, so you are just attempting 16 to 17 questions. Now, if you are attempting 16 to 17 questions and out of those questions you are getting only 12 or 13 correct, so obviously your score will be somewhere close to 45, 46. And that is not a good marks, because if I consider 45, 46 in chemistry, similar marks in physics and mathematics, so you will be getting up somewhere around close to 130. Okay, 130, 140 out of 300 is again not a good marks to get the top NITs. Okay, so you need to be very specific. Okay, you need to be very strategic at this point of time. Okay, build the right strategy, stick to that strategy, keep yourself focused and start memorizing things, because unfortunately this lockdown happened, unfortunately the spread of coronavirus happened, and like it's very sad and depressing to see how the world is like moving on. But still, as a student, we have got some little more amount of time. So if my preparation was weak, so I have got some 2 or 3 months more to prepare well. Okay, so I hope you are making this count, because this is the last phase of your preparation. After this, when you give your examination, then there is only a college where you have to attend your higher degree. Okay, so just place a right strategy. Okay, you have to make sure that you are reading the theoretical chapter. By theoretical chapter, what do I mean? You have to remember each and every structure that is written in NCERT, their uses. Okay, so this is a very critical chapter. You can expect a sure shot one question from this chapter. So you will procure 4 marks for sure. Similarly, biomolecules will definitely have one question. Okay, it will definitely have one question. So if you have gone through the lecture, if you have done in your institute, if you have done the revision, if you have solved all the previous year questions of JEE Mains as well as JEE Advanced, there is one question that is definitely coming from biomolecules. Similarly, polymers, chemistry in everyday life and प्रैक्टिकल ऑर्गेनिक केमिस्ट्री, इन 3 चैप्टर से आप एक्सपेक्ट कर सकते हो कि आपको एक क्वेश्चन मिलेगा ही मिलेगा. तो 3 क्वेश्चन तो इन 5 चैप्टर से डेफिनेटली आएंगे. I can bet on this, definitely आएंगे. If you want to secure those 3 questions, you have to just read them and memorize the important formula. Okay, so just focus on it. Make some strategy to remember those compounds. Okay, make some use of some mnemonics, helps in remembering the colors. Okay, if you try to find out a pattern of remembering the structure, you will definitely get it right. Okay, so 3 questions is confirmed from these 5 chapters. Okay, and that should be the strategy to move ahead. Okay, now beside these 3 chapters, there will definitely be a question on coordination chemistry. A definite question on coordination chemistry will be there, so it makes it 4. A definite question will there be from it will be there from solutions, 5. Okay, definite question from electrochemistry, 6. Okay, a definite question will come from alkyl halides, 7. A definite question will come from your alcohols, phenols, 8. A definite question on aldehyde ketones, 9. Okay, and in inorganic you can consider chemical bonding. There one question will be there in chemical bonding, 10. Okay, so if I prepare myself like that, I have a very clear idea and a clear strategy. I know that there are 10 questions that can be easily attempted by me if I focus only on these chapters very strongly. So if my preparation was very poor or didn't prepare for JEE at all, so if I am securing 10 questions in a paper, you are getting at least 40 marks. Okay, so you just need to find those questions which you will be able to do it. So scoring 60 plus in chemistry is very easy. I have seen many students, I am talking about many, I am not talking about few in number. I have seen many students who have cleared JEE Mains with a very good marks only on the basis of chemistry. When the paper was of 360 marks, I remember I trained a student back then in Haryana. So he was not good at all. So what marks did he get in his JEE Mains? Out of 360, I think he got something around 210. He prepared only for 4 months. 4 to 5 months was his preparation. He never prepared for JEE. Okay, he prepared in the 12th class. Right from October he started preparing, October, November, December, January, and a portion of February because in March he was having his board. And in April exam he got 210, I think. In chemistry he was having 110. Out of 120 he was having 110. And in physics and mathematics he did only what he knew of the 12th class. He didn't attempt any question of 11th class. Okay, so his strategy was right. He knew how to crack that examination and he got 210 marks out of 360. And I think he's right now doing his own startup. He's right now very famous in the fashion industry, and he studied computer science from Thapar University, Patiala. So there are many cases in which students have just used their strategy and cleared the examination. Okay, so for sure for JEE Mains you need to have one very strong chapter where you can go and we can get the full score, almost close to full score. If you have done that, then definitely will get a very good marks. Okay, so hope you have prepared a strategy for yourself. Whatever has been instructed to you at the platform, you are following it and you are doing it with all passion. Okay, because right now due to lockdown, the main problem like what I perceive is, if you look like I was just browsing through my Facebook page, so there are so many educators like who post get 70 plus in JEE Mains, get 85 plus in JEE Mains. So those people doesn't have a right strategy. It's just that they want a visit on their page, so they just post anything and everything. But what is more important is understanding of yourself, because what you are, okay, what concepts you have will help you in enhancing your marks. So the strategy only comes in the picture when you are ready to follow a certain guidelines. Okay, so don't get distracted. There are so many online platforms, there are so many YouTube channels where there are so many people teaching. Most of them does not qualify at the level of JEE examination. Most of the content that is delivered is poor. There is no clear-cut idea of what is being asked in JEE. There is no analysis done because most of them are amateurs. They don't have the experience of cracking the examination, and or they have not seen good number of students, I am talking about thousands of students cracking JEE, and definitely they have not seen the top ranks, how the top ranks are produced. So you have a very good opportunity, you have a very good privilege to study from the best educators of the country who have produced top rank, rank 1, rank 2. They have produced that in IIT-JEE, even in JEE means they have produced the topper. So you will get the enlightenment from them, you will get the path from them, just you have to blindly follow that path. Okay, so you have to believe in yourself that this can be done. Even if you didn't do well in your JEE mains, okay, even if you didn't have that much strong preparation of last 2 years, you got distracted, or the system in which you were studying was not friendly, it was more of pressurizing you, so you couldn't extract the best skills out of you. But you have been given now 2 months, you are in a, like you're in your home, in the most safest zone that you can have, and a most endearing and a most lovely place for each one of us. So just focus, dedicate your time to your studies, make a very strong schedule, make sure that you are the entire day is going in learning, okay, because this is only 2 months now. After 2 months, we sincerely hope with all the efforts of the doctors and all the scientists across the world that we come up with some medicine for the coronavirus and things become little more easy, life becomes more easy for each one of us. But after this everything is over, you need to be focused on your career, and career starts right away in the 12th class. So hope you are following it, hope you are giving out your best energy that you have, and hope you are performing, and hope you are going to crack this examination. Okay, so just this starts with a belief. Okay, JEE preparation starts with a belief, it ends with a belief. The process in between them is very important, where you have to keep yourself calm, where you have to keep yourself motivated. There would be many times when things would seem to be falling apart. Okay, there would be many times when you will not be getting very good scores, you will be tired of preparation, you will think that this is getting difficult and difficult every day, but you have to keep on moving through that journey, because that is how life goes. Okay, life is never a stagnant one. You have to be just in a one situation. Life always keeps on changing. There are always new things that are coming up in life. So you have to believe that this preparation which you have started say 2 years back, now you are about to end that preparation, it should give you the best possible result, and the best possible skills of you should be exposed in these examinations. Okay, so you have to stay focused, stay concentrated, stay away from everyone, just build a silence around you and study hard. Okay, if you are having a very good time slot, if you are studying for say 10 to 12 hours every day for next 2 months, if you even start from today, I promise you that there would be definitely a change in the result. Because this is like when I was in school, my parents also used to just push me to study. Okay, but as an individual, we don't understand the relevance of whatever our parents are saying or whatever is being instructed to us, because our mind generally tends to oppose the external guidance that has been given to us. But at the end of the day, when the examinations are near, we automatically sit and we automatically study. Okay, so because our mind also understand that now it is the time I should be more focused and I should be like focusing on my examinations. So now it is the right time now. Okay, we have still round about 2 months left. 2 months is a very big amount of time, because already you have given your board, you must have given your JEE mains, you must have revised all your topics. So there is still 2 months left. So make sure that these 2 months doesn't go in vain. You have to restart again, you have to focus again, focus on the theoretical chapters, focus on the basic concepts, because JEE main will ask those only. They will never go for high level problem solving or a conceptual question that is very difficult to crack. Okay, make sure that you remember all the physical chemistry formulas and the basic level problem solving and the NCERT of it. For inorganic, again same thing, you need to know your NCERT, okay, besides your copy, because the copy notes might be having much more reaction than what is there in NCERT. But you have to focus on NCERT, because most of the thing will be there from NCERT. Similarly for organic chemistry. Okay, so I hope you have noted it down that chemistry in everyday life, biomolecules, environmental chemistry, practical organic chemistry, okay, these chapters and polymers, these 5 chapters are very critical. Okay, there will be 3 questions on these topics. Okay, and similarly the 12th class physical chemistry is very important. By 12th class I mean about CBSE. solutions, electrochemistry, solid state, chemical kinetics, surface chemistry. So these 5 chapters you will again be definitely having 4 questions on these topics. Okay, so 3 plus 4, 7. Coordination, transition, there will be definitely 2 questions. Okay, 9 questions. Similarly, there are important organic reactions. There will be questions on them as well. So you can easily predict 12 to 13 questions that are about to come in your JEE Mains paper, because they are the core sciences, they are the core fundamental concepts from where the people in JEE, the people at NTA will check you. Okay, so just make a right strategy, push yourself hard. Time might seem difficult to you. It was always difficult when I was preparing. It will be difficult for the people who will be giving the JEE Mains or JEE Advanced next year. So it will always be there. Whether you get time or whether you get less time, that pressure scenario is with everyone. Even it is with the people who are doing the job. So this is how real life behaves. Now you are graduating from your schools now. Okay, now you are entering into the next phase of your life that will demand a development of new skills on you. Okay, so let's focus, let's make this process a very enriching one, a very learning one, and let's crack this now. This has to be taken in a personal challenge, you can say, that I have to crack this examination. I have been given some more time to this, and believe me, life at the top institutions is much different from life at the normal or the private colleges. If you choose IIT, if you get into IIT, then that is the best thing that can happen to you. If you are even in NITs, top level NITs or top level private university like BITS Pilani, Thapar University, then also your life will be very good. But if you are not in these, like say in these 50 colleges, 60 colleges, these 60 colleges will definitely give you a much better professional outlook about your life, about your ambitions, about your dream, and they will give that platform where you can rise and keep rising and achieve whatever you want to do in your life. But if you go to a 3-tier level college, then things would become very difficult from there. Okay, because a good placement over there is very difficult. A good academic session is also very difficult in those colleges. They are basically not equipped with the engineering that is required to train the students. Okay, so we have some 65 colleges, 70 colleges in India that are actually good, and they have a good number of seats. So almost 1 lakh engineers that are produced in India are from these colleges only. So 1 lakh is a very big amount of seat. So you just don't think about the competition, how many students are giving. You just look at your own probability. You have to get 1 seat among those, say 70, 80 or 90 or a 1 lakh student. So your probability of selecting is like very high, okay, because number of seats is like very large, okay, is a very huge number. So you just need 1 seat. You have to focus hard. You just don't think about what your friends are doing, what the topper of your school is doing, what the topper of your institute is doing. It hardly matters to you. What should matter is your own performance, how I am going to improve my own performance, how I am going to develop these strategies, and what are the shortcut tricks, mnemonics that I am going to adopt to make things very easy. Okay, so let's start with the chapter today. Okay, so I have already discussed some basic chemistry in everyday life when I was doing, I think, coordination chemistry, okay, or when I was doing the electrochemistry solution portion. So we have already discussed 2 very important things, that is sweetening agents, artificial sweetening agents. We studied the structures of allitame, we studied the structure of sucralose, we studied the structure of saccharin, and we also studied for aspartame. Okay, so these were the 4 artificial sweetening agents. Aspartame was 100 times sweeter, okay, than the normal sugar. Okay, saccharin was 550 times. Okay, allitame was I think 600 times, and sucralose was 600 times, and allitame was 1000 times sweeter. Okay, so this was the basic thing that we did. We also tried to remember their structures. Hope you have now memorized those structures and you are very clear. Okay, and then after that we did was a very important portion, that is analgesics. We divided analgesics into 2 portions, narcotics and non-narcotics. Okay, narcotics are those which are not available for public use. Okay, they are sold illegally in many of the countries, codeine, morphine and heroin. Okay, we did the structure of those compound also. And non-narcotics, we did aspirin, paracetamol, ibuprofen. Okay, so these were the basic structure which we tried to memorize. Okay, I hope you have memorized those structure. What you can do to practice is, you can just, whenever you are having 5 to 10 minutes, just try to recall those structure and draw on a paper. Okay, do it every time, do it every day. You will see after 10-15 days you will be thorough with those structures. Okay, so let's start with the lecture today. So today the first point is, which we are going to discuss, is antacids. Okay, now what are antacids? Now we know that every one of us have faced acidity. So acidity is basically when our stomach releases more of intestine, or the stomach releases more of acid. Okay, so when the acid content is more inside, so we get lot of burping. So that is basically your acidity, or it is called as, okay, the acidity itself. Okay, so whenever the body has secreted, or the intestine has, or the stomach has secreted more of the acid, so the acid accumulates and it causes, okay, the acid accumulates and it causes acidity. So if we want to remove that acidity, what we take, generally we take a syrup known as Gelusil, okay, or milk of magnesia. Okay, so what we are doing, we will take some antacids. Antacids are those compounds or those drugs which help in reducing the acidity. So because the stomach has produced acid, so what we are going to consume, we are going to consume a base. So base will neutralize that acid, okay, so that the conditions are restored. So the common examples are sodium hydrogen carbonate. You must have seen ENO. Okay, ENO is a very common constituent that is found in almost all the homes. Okay, so this is basically chemistry in everyday life, chemistry in everyday home. Okay, so most of the things is there in your home. You just need to connect with them, okay, with the things that you have seen in your home, then things become very easy to memorize. So you must have seen ENO. When you add water to this, it gets a lot of bubbling, okay, because ENO is basically having NaHCO3. When you add water, HCO3 negative hydrolyzes, H2O plus CO2 is produced, and that CO2 comes out. Okay, so if you look at sodium hydrogen carbonate, we know that sodium hydrogen carbonate is made up of NaOH and HCO3. Okay, so NaOH and H2CO3, so it is basically a basic compound. Okay, so sodium hydrogen carbonate, or aluminum and magnesium hydroxide. Magnesium hydroxide is also called as milk of magnesia. Okay, so whenever we are having acidity, we will consume sodium hydrogen carbonate, which is basic in nature, or aluminum hydroxide or magnesium hydroxide. However, excessive hydrogen carbonate can make the stomach alkaline and trigger the production of even more acid. Okay, so if you have NaHCO3, so it basically increases the pH and makes the entire solution inside the stomach alkaline, and that triggers more production of acid. So generally nowadays we don't use sodium hydrogen carbonate, okay, or any metal hydroxide like aluminum or magnesium hydroxide. Milk of magnesia is still used. Okay, so metal hydroxides are better alternative because of being insoluble. They do not increase the pH above neutrality. Okay, so these compounds are much better than sodium hydrogen carbonate. Okay, a major breakthrough in the hyperacidity came through the discovery according to which a chemical substance, histamine, okay, so histamine stimulates the secretion of pepsin and hydrochloric acid in the stomach. Okay, so antacids, just you have to follow whatever I am saying. You just keep on repeating the important compounds while I am teaching, so that you will be able to memorize it much more easily. Okay, so antacids, okay, reduces acidity. Okay, so what are the compounds that we can consume? It is NaHCO3, sodium hydrogen carbonate, aluminum hydroxide or magnesium hydroxide. Metal hydroxides are better because they are less toxic, and generally they are less soluble, okay, and they will maintain neutrality. Whereas sodium hydrogen carbonate, when consumed, makes the solution inside the stomach alkaline, that causes or that triggers the production of more acids. Okay. Now again a major breakthrough came when there was a compound known as histamine, okay, that was formulated, okay, that stimulates the secretion of pepsin and hydrochloric acid in the stomach. Okay, so now let us look at these histamines. Okay, so the drug cimetidine, okay, the drug cimetidine, Tagamet, was designed to prevent the interaction of histamine with the receptors present in the stomach wall. Okay, this resulted in the release of lesser amount of acid. The importance of the drug was so much that it remained the largest selling drug in the world until another drug known as ranitidine or Zantac was discovered. Most of you might have seen this Zantac in your home. Okay, whenever there is acidity, so people generally consume Zantac, or it is also chemically known as ranitidine. Okay, so basically if you look at the structure of them, okay, so we are talking about histamines, cimetidine. Cimetidine is called as Tegamet, or Zantac, which is called as ranitidine. Okay. Now let us look at the structure. So this is basically the structure of histamine. Okay. Now the structure of histamine is very important. I have seen 3 times the question on histamine. Okay. One was the like the charge on it at different pH. Okay. Direct question. Okay, and the basicity question. So 3 times the question has been asked on this. So if you look at the structure of histamine, now how we'll remember the histamine. Okay, so basically in histamine there is a very important segment, okay, which is a histidine. Okay, now every one of us know that histidine is this. Okay, we have done this in amino acid as well. If you have not seen the amino acids lecture, you can see it in the catch up video. So this was basically, and you connect it with a carbon. Okay. So you have a amino acid portion over here, so that we call that as a histidine. Okay. So if you look at this, this is a histidine. Okay. So in this, just we have to add 2 carbons and a NH2. So this is called as a histamine. Okay. So histamine is derived from histidine. Now histidine is basically, okay, just keep on drawing on your paper so that the structures are memorized. So this is the structure of okay. So this is the structure of okay. This is the structure of histamine. Okay. So basically it is having 3 nitrogens. So 5-membered ring, 3 nitrogens. Okay. A double bond over here, a double bond over here. Okay, so this is called as a histamine. Okay, so hope you know this structure now. So this structure is known as histamine. Okay, next comes is the cimetidine. Now cimetidine and ranitidine structures are little difficult to remember, but anyways you have to remember this. Question can come something like this: the percentage of nitrogen in histamine. Okay, so we know that there are 3 nitrogens, so it will contribute 42. As the in the total molar mass, you have to calculate total mass. Total molar mass 42 divided by total molar mass into 100 will give us the percentage of nitrogen. Similarly, it can be asked number of nitrogen in cimetidine. Okay, number of say oxygen in ranitidine. So questions like this are coming in JEE Mains. It is critical. It is important. So you have to focus. Okay. So if you look at the structure of cimetidine, it also has a histidine type of system. Okay. Now it has a histidine type of system. Okay, there is a methyl over here. Now 2 carbons, NH2 was histamine, 1 carbon, then a sulfur, then again 2 carbon, NH, C double bond NCN, NHCS3, NHCCS3. Okay, so this is the structure of histidine. Okay, so a histidine ring, okay, 1 carbon, sulfur, 2 carbon, nitrogen, okay, 2 carbon nitrogen, then a carbon with a double bond N, CN and NHCS3, and there was a methyl over here. So it can, the question can also be like this: number of carbon in cimetidine. Okay. So let me just do it. See, this is the way how I memorize, and I find it much more easy to memorize them. Okay. So if I talk about histamine, okay, so this would be the structure of two carbon and a NH2. So this is the structure of histamine. Okay. So this is a very clear structure. Okay. Now out of these 2 nitrogen, we know that this nitrogen would be basic, because if you do the resonance there will be a negative charge on this nitrogen, so electron density on the nitrogen would increase and basic strength of this nitrogen would increase. Okay, so this was your histamine. Okay, now if we talk about cimetidine, okay, which was also called as tegamet. Okay, say cimetidine, tegamet, cimetidine, tegamet. Okay, so same thing. You have to keep saying along with me so that I would be more effective in memorizing. Okay, making you memorize all those concepts. So 1 carbon sulfur, 2 carbon nitrogen, okay, C double bond N CN NHCH3. Okay, so this is the structure, cimetidine. Okay, hope this is clear to you. Okay, hope this is clear to you. So there will be certain patterns to memorize the reaction. Okay, histidine portion remains the same. Okay, here after 2 carbon nitrogen was there, first carbon sulfur, after 2 carbon nitrogen, and then C double bond N CN NHCH3. Okay. Now let us look at the structure of ranitidine. Now this is an important structure. Now this can come as a question. So this is basically also commercially called as Zantac. Okay, so this is the highest selling drug across the globe. So if you look at the structure, okay, so the segment over here remains the same. Okay, only instead of N there is a CHNO2. Okay, CHNO2, everything is same. And similarly this segment goes out and here we are having a carbon and a 2-degree nitrogen. Only difference is the ring is having a furan. Okay, so the question can come like this also, which of the following drugs contains a furan ring? Okay, it can be say histamine, cimetidine, ranitidine and any other molecule. Okay, so let us do the structure again. Hope you have, just look at the structure. Okay, just have a look at the structure. Furan, sulfur, 2 carbon, nitrogen, followed by a carbon double bond C, okay, HNO2 and NHMe, and here 1 carbon and 2-degree nitrogen. Okay, now once you have seen the structure, let us draw the structure. Okay, so we know there would be a furan ring. Okay, now I know these are little boring, these are having no conceptual approach, but this is important, so we have to focus and we have to memorize. Okay, so this was the segment. Okay, so cimetidine and histamine. So you have to start with histamine. Histamine has a histidine ring, cimetidine has a histidine ring. Okay, then furan, just 1 carbon nitrogen, 1 carbon sulfur. Okay, so furan, this is 1 carbon sulfur, 2 carbon nitrogen, followed by C double bond CHNO2. Okay, in cimetidine it was C double bond NCN, C double bond NCN. In this it is C double bond C NO2, then NHCH3. Okay, and at this position it is 1 carbon and NMe2. So this is the structure of ranitidine or Zantac. Okay, so we'll keep revising it in between the lecture. Hope you are drawing it with me. Okay, hope you are finding a pattern to memorize them. Whatever I am saying, you are just listening and you are practicing. Okay, a pen and a paper at this stage is very important. Okay, now there were some compound that is antihistamines. So histamines were basically a potential vasodilator. Okay, so it has various functions. It contracts the smooth muscles in the bronchi and guts and relaxes other muscles such as those in the walls of fine blood vessels. Histamine is also responsible for nasal congestion associated with common cold and allergic response to pollen. So again a very important term which you have to remember. We don't want to enter into the biology aspect, we will just remember the formula and the important thing it is causing. Okay, so histamine is basically a potential vasodilator. Okay, histamine is basically a vasodilator. Okay, so there are two structures, okay, for antihistamines. These are bromophenaramine or terfenadine. Okay, this is commercially sold as Seldane. Okay, these structures are little difficult to memorize. So you can just have a photo of this. This is there in the NCERT. We'll come to these structures at the last. Okay. So next is the antibiotics. So basically antibiotics belong to a group known as antimicrobials. Antimicrobials are basically antiseptics, okay, disinfectants or antibiotics. So an antibiotic compound tends to destroy, prevent development or inhibit the pathogenic action of microbes such as bacteria, fungi or virus, okay, or other parasites selectively. Antibiotics, antiseptics and disinfectants are antimicrobial drugs. So when you consume a antibiotic, okay, it produces certain microbes, okay, that microbes goes and cures us by either inhibiting the growth of the virus or the bacteria that is there inside the body, or they generally kill them, okay. So antibiotic is now referred to a substance produced wholly or partially by chemical synthesis which in low concentration inhibits the growth or destroy microorganism by intervening in their metabolic processes. Okay, so when you consume an antibiotic, so antibiotic what it does, it goes and stops the metabolism or it stops the growth of the virus or the bacteria or the parasite that is there. Also it can kill them. Okay, so common examples of antibiotics. So antibiotics is again a very important portion. Many questions can come from this. Paul Ehrlich basically started the discovery of many antibiotics. So initially he was working on some other chemistry of inorganic portion. He found that AH double bond AS, that is arsenic double bond arsenic, is having a lot of antimicrobial property. So he developed a compound which is known as ursphenamine. Okay, so this is called as ursphenamine. Okay, so in ursphenamine, so basically you have to remember ARS. So it is basically having arsenic bond. Okay, so AH double bond AS. Okay, so I just draw over here. Okay, so this is basically ursphenamine. So this is having AH double bond AS, okay, and two benzene ring on both the sides of arsenic. Okay, ursphenamine ARS, arsenic, okay, AH double bond AS. And if you look at this, at para position there is a OH, at para position there is a OH and a NH2 at the meta position. Okay, you can draw something like this. Okay, so this is basically ursphenamine. Okay, now question can be, is this geometrically active? This is geometrically active because it will have a lone pair also on it. So if the lone pair are in the same direction as in the cis case, so it will be called as syn, and if the lone pairs are opposite, it will be called as an anti-isomer. Okay, so this is an example of ursphenamine. So what I am saying in ursphenamine AS, so there is a AS double bond AS, okay, a benzene ring attached to both the arsenic. There is a OH at the para position and NH2 at the meta position. Okay, dot 2 HCl is the structure of ursphenamine. Then the second structure, okay, now because he found out that there is some antimicrobial, Paul Ehrlich basically found out that there is a antimicrobial property associated with AH double bond AS. So what he started doing, he went to that particular group in which arsenic is there. Okay, so he also found that N double bond N, which is a azo bond, is also a possessing antimicrobial property. Okay, but the problem with them was they were basically dyes. So when we are consuming it, the tissue became colored. So he again reinvented and he again found new compounds. So azo dye is basically we are forming the phenol azo dye. Okay, so just remember this is a phenol azo dye. Okay, azo dye is basically prepared by reacting benzene diazonium chloride, okay, with a phenol. When you react this with a phenol in basic medium, so this will attack from para position and you will form a azo dye. Okay, so phenol azo dye, ursphenamine, okay, AH double bond AS, benzene para, it is a OH group, so this is also having a phenolic group. Okay, so AH double bond AS, para OH, so again a phenolic group, NH2 at the meta position. Okay, so in azodie, it is a azodie of phenol. Then he again made some structure modification. Sulfonamide, he came to a compound which is sulfonamide type of structure. Sulfonamide is basically having S double bond O double bond O NH. Okay, so they also possess a lot of medicinal properties. So what he did some structure modification of this, and he designed a compound which is known as Prontosil. Okay, the first compound was, just repeat it with me, the first compound was, your father mother should know that you are studying, okay, at Yup Master. So you should keep speaking so that they also see that, okay, our child is just trying to learn. Okay, so the first compound is arsphenamine. Arsphenamine is basically having AS double bond AS, okay, and then benzene OH OH at the para, NH2 NH2 at the meta position. Okay, azodie, phenol of azodie. Oh sorry, azodie of a phenol, that is phenol, N double bond N and a benzene ring. Third was Prontosil. So basically he did a structure modification of this. Okay, so he came up with a compound which is known as Prontosil. Okay, so in Prontosil, so he basically had S double bond O NH2, and in this case NH2 at the para and NH2 at the ortho. Okay, so again I think this is a very important question that can come, number of nitrogen in Prontosil. So they basically we are having 5 nitrogen atom. JEE means integer type question. Okay, so let us just try. So this is S double bond O NH2. So basically they are called as sulfamides. Sulfamides have lot of medicinal properties. Okay, they find a lot of if you look at soframycin, if you look at any of the compound, basically the creams, antiseptic cream, they will definitely have sulfur. So sulfur has a very good medicinal property. So basically they modified the sulfur and converted it into a sulfamide, which is also again a very important drug. Okay, so the next compound was Prontosil. Prontosil is basically the extension of azodie, N double bond N, 2 benzene ring attached to nitrogen. Okay, and at the para of one was NH2, para of one was S double bond O NH2, and to one ring at ortho there was a NH2 group. Okay, so this is the basic structure of Prontosil. Okay, now look at the sulfapyridine. Okay, so this is again very important. So now what is happening, just look at this structure. So sulfapyridine is basically, you can clearly understand there is a pyridine ring in it. Okay, so we already told you that this is your sulfamide linkage. Okay, so this was basically attached to a pyridine. Okay, and there is a NH2 at the para position. So this is basically called as sulfapyridine. Okay, benzene ring S double bond O NH, pyridine attached to NH. So this is sulfapyridine and a NH2 at the para position. Okay, so I will just revise it again, so don't worry. So just I hope you are drawing these structures parallelly with me. Last was sulfanilamide. Okay, in sulfanilamide it was basically, you get just this. Okay, just remove the pyridine. So you get benzene S double bond O NH2, at para you are having NH2. So this is called as sulfanilamide. Okay, so just have a look at the structure. So we are having basically 5 types of antibiotics. The first antibiotic was arsphenamine. Okay, arsphenamine, AS double bond AS. Okay, then came azodie. Okay, from azodie came Prontosil. From Prontosil we reached to, okay, sulfapyridine. From sulfapyridine we reached to sulfanilamide. Okay, so now let us just revisit the structures again. So we are talking about 5 structures: arsphenamine, azodie. Okay, then we are talking about Prontosil, we are talking about sulfapyridine, and we are talking about sulfanilamide. Okay, so just let us look at the structure. So the first structure that was I am talking about is, now just draw along with me. So let us see whether you have been able to crack the structure or not. So arsphenamine. Okay, so in arsphenamine we were having that AS. Arsh is having AS word, so arsh. Okay, so this is having 2 benzene ring. Okay, now we know that at para there would be OH, Okay, so there is a NH2, there is a NH2 over here at the meta position. Okay, the second was azo dye. Okay, now azo dye, किसका azo dye है? Phenol का azo dye. Okay, so this is a azo dye of phenol. So phenol, the problem was this was having color. So this was imparting colors to the tissue which we didn't want. So we modified it. Okay, and we came to a new compound. Okay, that was known as prontosil. Okay, that was known as prontosil. Okay, so in prontosil what we are saying, it has the same type of azo dye structure. A sulfamide group has been introduced. Okay, so there would be a NH2 at the para of this. Okay, and S double bond O NH2 sulfamide group, NH2 at the para. Okay, and one NH2 at the ortho. Okay, easy to remember. Hope you are not facing much of difficulty. The fourth structure was sulfapyridine. Okay, sulfapyridine. So this will have a pyridine ring. So basically now we have, from here we have understood that there will be S double bond O NH2 in the structures because it is having a medicinal properties. So it was basically having S double bond O NH. Now to this a pyridine ring was attached. Okay, and at the para position there was a NH2 group. Okay, and the last, this is basically pyridine, and the last was sulfanilamide. Okay, so this is basically having, okay, so okay, so this is the structure of sulfanilamide. Okay, now hope you have memorized these structures. Okay, hope you have got these structures right. Okay, so there is a pattern, you keep drawing them, you try to make some on based on their name what you can do. So there are 5 basic antibiotics that we have done till now, that is erschphenamine, okay, erschphenamine, azo dye extension, prontosil. Now after that sulfamide group will be there. Okay, so that is prontosil. After prontosil was sulfapyridine, and after that was sulfanilamide. Okay, so let's go again. So this compound is known as chloramphenicol. Okay, so and this is known as penicillin. Okay, so you might have seen a lot of question on this in JEE Mains this year. There was a question of number of chiral atoms. Okay, in penicillin there was a question of number of chiral atoms in chloramphenicol. Okay, so this molecule is basically called as penicillin and this is called as chloramphenicol. So if you look at the structure of penicillin, so we know that there would be a nitrogen in a 4-membered ring and a sulfur in a 5-membered ring. Okay, just directly attached to the ring. Okay, so a 4-membered ring containing nitrogen. Okay, at the fused end, this is a bicyclofused, okay, junction. So there is a nitrogen at the fused junction in a 4-membered ring. 5-membered ring we are having a sulfur. Okay, just carbon adjacent sulfur has 2 methyls. Okay, now the carbon just beside that is having a carboxylic acid group. So that is going inside the plane. So this is basically having COH. Now it is having a amide type of linkage. So this is double bond O, and there is a amide type of linkage over here, NH. This is coming outside the plane, C double bond O OR. Okay, so this is a general example of penicillin. This is not exactly penicillin because R group can change. So general structure follows like this. So if you can see, there are, this is one chiral atom attached to different group. This is the other chiral atom attached to 4 different group. This is the other chiral atom attached to 4 different group. And this nitrogen, because it is present at the bridgehead position, okay, so the lone pair cannot enter into resonance. So this will also be considered as a 4 different group. So total number of chiral atom in this is 4, okay, and the number of chiral carbon is 3. So this is the structure of penicillin. Okay, a 4-membered ring having a nitrogen, okay, then a double bond O, so that amide type of linkage you are considering, and then again a amide type of linkage NHCO R. So okay, so like structure draw like this, a nitrogen in a 4-membered ring, okay, double bond O, amide type of linkage, then a amide that is outside the ring. Okay, now join it with a 5-membered ring with a sulfur. So you get this, okay, just adjacent to sulfur there are 2 methyls, and at this position they are having COH. Okay, so the question can come, which of the following drug contains peptide linkage or the amide linkage, or evolves CO2 gas with NaHCO3, or contains COH group. Okay, so this is your basically the structure of penicillin. Okay, so penicillin G has a narrow spectrum. Okay, ampicillin and amoxicillin are synthetic modifications of penicillin. They have broad spectrum. Okay, so basically the penicillins are used to treat gram positive and gram negative, okay, bacteria. So if it can treat both, then it is called as a broad spectrum. If not, then it is called as a narrow spectrum. So penicillin G is a narrow spectrum. Okay, now you might have heard about amoxicillin. Okay, amoxicillin is a very common antibiotic which we consume during fever. Okay, so amoxicillin, okay, amoxicillin, ampicillin, they are again broad spectrum. Okay, they are broad spectrum antibiotic. Penicillin G is basically a narrow spectrum. Okay, now this molecule is called as chloramphenicol. The structure is again very important. Okay, so if you look at the structure, so we are having a benzene ring. At the para position we are having NO2, okay, CHOH, CHNH, COCHCl2, CH2OH. So you can clearly see that there are 2 chiral atoms in this. So this is called as chloramphenicol. Okay, so this structure is called as chloramphenicol. So if you want to remember the structure, benzene, okay, at the para position we are having NO2, benzene para position NO2, okay, then CHOH, CH, then we are having NHCOCHCl2, and this is having NHCH2OH. Okay, so this is the structure. So if you look at the chloramphenicol, it was isolated in 1947 as a broad spectrum. Okay, it was a broad spectrum antibiotic rapidly absorbed from the gastrointestinal tract and hence can be given orally in case of typhoid. So chloramphenicol is a very important drug that is used for treatment of typhoid. Now this question has also come. Okay, so chloramphenicol is used for treatment of typhoid. Okay, dysentery, acute fever and certain form of urinary infections, meningitis and pneumonia. So chloramphenicol is basically used in treatment of typhoid, pneumonia, meningitis. Okay, so these are the 2 very important drugs. Okay, questions are expected to come from penicillin and chloramphenicol. So in a penicillin we are having a 4-membered ring, nitrogen in the 4-membered ring, C double bond O just adjacent to the nitrogen, amide type of linkage, then at the next carbon it is NHCOR, okay, N double C double bond O NHCOR, okay, so 2 amide, then there is a sulfur ring in a 5-membered, okay, 5-membered ring containing a sulfur, adjacent carbon 2 methyl and then COH. Okay, in chloramphenicol we are having benzene, okay, NO2 at the para, okay, CHOH, then we are having CH, NH, C double bond O, CHCl2, CH2OH attached to this carbon. Okay, so this is the structure of chloramphenicol. 1 chiral carbon and 2 chiral carbon in that atom, in that 3 chiral carbon atom in this. Okay, so ofloxacin is again a very important broad spectrum antibiotic and vancomycin. So you need to remember the name. Questions can directly come, which of the following are broad spectrum or which is not a broad spectrum. So penicillin G is a narrow spectrum. Amoxicillin is commonly used in homes. If you have a medical box in your house, you can see that a common compound amoxicillin would be there because somewhere we have consumed this compound for fever. Okay, so amoxicillin, ampicillin, okay, ofloxacin, vancomycin, they are all broad spectrum. Chloramphenicol is also broad spectrum, used for treatment of typhoid. Okay, chloramphenicol is used for treatment of typhoid, meningitis and pneumonia. Okay, now there are 2 types of, this is again a very important conclusion, there are 2 types of antibiotics, one that kills the okay, virus or the bacteria present, and other which inhibits the growth, okay, or which destroys its metabolic activity. So that is known as bacteriostatic, which kills is known as bactericidal, okay. So the antibiotic which is killing the bacteria or the virus, that is called as bactericidal, and the other which is just inhibiting the growth, that is called as bacteriostatic, okay. So if you look at example of bactericidal, that is penicillin, aminoglycosides and ofloxacin. Ofloxacin we have done it now, it is a broad spectrum, okay. Bacteriostatic is erythromycin, tetracycline and chloramphenicol, okay. So you can remember this as ETC, okay, ETC, okay. C is your chloramphenicol, T is your tetracycline, E is your erythromycin. So if you even remember this, you can look at the option, you can guess it which is the correct option, okay, because you can easily eliminate erythromycin, it starts with E, tetracycline it starts with T, and chloramphenicol it starts with C, okay. Now for this it is POW, okay. I don't know how many students know about POW. It's a very famous dish in, or the, like most of the people consume in the morning, POW, okay, pav bhaji, vada pav, okay. So P for penicillin, A for aminoglycides, O for ofloxacin, okay. So two types of antibiotics, bactericidal, cidal means that kills, okay, bactericidal POW, PAO, okay, bactericidal POW, penicillin, aminoglycosides, ofloxacin, okay. Bacteriostatic that inhibits the growth or slows down the metabolism of the virus or the bacteria that is inside. So the common example is ETC, okay, ETC etc. ETC means erythromycin, T means tetracycline, C means chloramphenicol. So POW ETC, POW ETC, you have to remember like this, POW ETC, okay. So if you are smart enough, you can easily judge in your paper which is the correct option, okay. Next comes is the antiseptics. Now we know what are antiseptics. Basically everyone might have applied Dettol, okay, in their childhood, okay. It burns a lot when you apply Dettol on your wounds. So basically they are applied to the living tissues such as wound, cuts, ulcers and diseased skin surface to stop the growth of bacteria, because the wounds are exposed to the air. So there are so many bacteria in the air, so the bacterial growth can take place on those wounds. So we just wash it with antiseptic so that if any bacteria comes in contact with it, it will die, okay. The common examples are, okay. Now just look at these common examples. Most of them you know because you have encountered, okay, them. So the first common one is your Dettol, okay. So the first common one is your Dettol, okay. So the first common one is your Dettol, okay. Dettol is basically mixture of two compounds which is chloroxylenol, okay. I hope you know this, chloroxylenol and terpineol, okay. So Dettol is a very common antiseptic. Soframycin, okay. Soframycin is again a very important cream that you might have seen in your home. Dettol, soframycin. Similarly boric acid, okay. Boric acid is basically used in eye washing, okay. So this is basically used in eye washing. Iodoform tincture of iodine, they are again used in wounds, washing the wounds, okay. Biothianol is a very special one, so we'll have to remember this, okay. This is important, and furacin, okay. So let us look at their structures now. So basically Dettol is chloroxylenol and terpineol, okay. Chloroxylenol, okay. Xylene, so there is a word xylene over here, okay. You can see there is a word xylene. Xylene means benzene having two methyl groups, okay. Toluene is benzene with one methyl, xylene is benzene with two methyls. So in chloroxylenol we are having two methyl in a benzene ring. So we are having two methyl in a benzene ring, okay, meta to each other. There is a chloroxylenol, so chloroxylene, okay. So the two methyls are separated by a chlorine, chloroxylenol, OL. So there is a alcohol over here. So there is a chloroxylenol, okay. So basically you should know this, This is the common IUPAC name or the common name. Toluene is benzene with 1 methyl, okay. Xylene is benzene with 2 methyls. So there are 2 methyls, they are separated by a Cl, and at para we are having OH. So this is basically chloroxylenol, okay. Terpinol is basically a 6-membered ring, okay. Okay, terpinol is again having a OH. So this is a 6-membered ring, okay. And the C1 and the C4 carbon has 2 groups, methyl over here and a 3-degree alcohol over here with a double bond at this end. So this is basically terpinol, okay. Chloroxylenol, terpinol. So Dettol is basically the mixture of these two, okay. So Dettol is basically the mixture of these two, chloroxylenol and terpinol. Chloroxylene, xylene means 2-methyl to a benzene ring, and in between there is a Cl, opposite we are having OH, okay. In terpinol we are having a 6-membered ring. The opposite group has a methyl group and a 3-degree group with a double bond. Next comes is the bithionol, okay. So if you look at the structure of bithionol, now this is the little tricky structure, okay. Bithionol is added to soaps to impart its antiseptic properties. Iodine is again a very powerful antiseptic. Its 2 to 3% solution, okay, in alcohol water mixture is known as tincture of iodine. You must have seen that brown type of solution in hospitals, they apply on the wounds. So it is basically tincture of iodine. So it is 2 or 3% of iodine in water ethanol system. It is applied on wounds. Similarly, iodoform is a antiseptic for wound, okay. Boric acid in dilute form is used in eye washing, okay. So antiseptic for eyes. Bithionol is basically added to soaps to impart antiseptic property, okay. So if you look at the structure of bithionol, okay, because it is having a word thio means sulfur. So okay, it means that we are having 2 benzene ring, okay, thionol. So it is basically having, okay, OH on it. So there should be 2 OH at the ortho and then Cls, okay. So OH, Cl. So this is basically a symmetrical structure. Whatever groups are there is present over here, okay. So bithionol is basically having a sulfur, 2 benzene rings, okay. Bithionol, OH, so there would be 2 OH, okay, 1 Cl over here, 1 Cl over here, 1 Cl over here, 1 Cl over here, okay. So furacin, soframycin, Dettol is a mixture of chloroxylenol and terpinol. Bithionol are used in soaps to give antiseptic properties. Tincture of iodine is 2 to 3% of iodine in alcohol water mixture. Iodoform is used again in washing wounds. Boric acid is antiseptic for eye, okay. Next comes the disinfectant. Now we know about disinfectant. Generally the floor washing which we are doing at home is a disinfectant. So disinfectants are applied to inanimate objects such as floor, drainage system, instrument, etc. Such substance act as antiseptic as well as disinfectant by varying the concentration. For example, 0.2% of phenol is an antiseptic, its 1% solution is a disinfectant. So you must have, you can easily guess this, okay. So generally in the home we wash our, okay, floors through phenol, okay. So that is also, you can also remember this, phenol is also called as carbolic acid, okay. Phenol is also known as carbolic acid, okay. When you enter into the hospital, you get a very distinct, okay, smell, okay, that is basically of phenol, because phenol is having a disinfectant property, so it is always washed with phenol. So a lower concentration solution is used as an antiseptic, 0.2% solution is used as an antiseptic, greater than 1% is used as a disinfectant. Similarly, chlorine, you must have seen in the swimming pools, okay, generally in the swimming pool in the night they spread chlorine, they spread the chlorine powder on it, so it acts as a disinfectant, okay. So whatever germs that has gone through the human body in that will get disinfected, okay. So chlorine in the concentration of 0.2 to 0.4 picometer in aqueous solution, okay. These are generally used in disinfecting water, okay. Sulfur dioxide is also a disinfectant. So the common example of disinfectant is phenol. 0.2% is basically a, it is basically a antiseptic, okay, and 1% or more concentration solution is always a disinfectant. Chlorine is again a very important, okay, for disinfectant for water in the range of 0.2 to 0.4 ppm, okay. Similarly, sulfur dioxide is also a very good disinfectant. Okay, hope this you have. Okay, so till now just to revisit whatever we have done, because we have done lot many structures right now. So the first thing which we started today was with the structure of antibiotics. Okay, I think we started with antibiotics, right? No, sorry, we started with antacids. So antacids are basically the compounds that are used to cure the acidity. The common examples are NaHCO3. NaHCO3 is less used because it increases the pH inside and causes more release of acids. The second was magnesium or aluminum hydroxide. They are better alternative because they are insoluble and they do not increase the pH above neutrality. Okay, major breakthrough came when we invented histamine. Okay, that stimulates the secretion of pepsin and HCl in the stomach. Okay, so we did the structures. Okay, so just we'll revisit the structure without looking at them. Histamine was basically a histidine ring and 2 carbon connected with a NH2. Okay, then we read about cimetidine, which is also known as tegamet. So in cimetidine we had same the histidine ring. Okay, after 1 carbon there was a sulfur, after 2 carbon there was a nitrogen attached to a carbon containing double bond NCN and NHCS3. Then we came at ranitidine, which is also called as Zantac. So that has a pyrrole ring. Okay, so that has that has a furan ring. Okay, and at like just the adjacent position of the oxygen, at one end there was a carbon followed by a 2-degree nitrogen. Okay, and at the other end, similar to that of ranitidine, 1 carbon sulfur, after 2 carbon nitrogen, then C double bond. C here was, okay, in tegamet it was C double bond N, here it is C double bond C, H NO2, and then that carbon is attached to NHCS3. So this was the structure, that NHMe. Okay, then we came to antihistamines. So antihistamines are basically bromophenidamine and celdane, also known as terfenadine. Okay, you can look at these structures. Now these structures according to me is not much important. Then we came to antibiotic. The first antibiotic that we did was arsphenamine. Arsphenamine, there are AH double bond AH, 2 benzene ring. Okay, at the para there were 2 OH, and at the just ortho to them were NH2. So after that came azodai of phenol. Okay, and then it was modified, known as prontosil. So this is basically a benzene ring. Okay, prontosil was basically a benzene ring. Okay, from here you should remember that we introduced sulfamides. Okay, so there is a modification of azodai. So benzene ring, N double bond N, again a benzene ring. Okay, at the para position we are having NH2, and its ortho meta position or the ortho of this is having NH2, and this is having H double bond O NH2. Then came sulfapyridine. Sulfapyridine was basically benzene ring, H double bond O NH. That is there is a pyridine ring, and then at para there is a NH2. Okay. Then came sulfenilamide. Okay, benzene ring, H double bond O NH2. Para we are having NH2. Then came 2 very important compound, that is penicillin G, that is a narrow spectrum. Okay, chloramphenicol, that is a chloramphenicol is used in treatment of typhoid, pneumonia, meningitis. Okay, this is a broad spectrum. Other example of broad spectrum were ampicillin, amoxicillin. Okay, also ofloxacin and vancomycin. Okay, so only penicillin G was narrow spectrum. Okay, structure we have, remember these structure was easy. Chloramphenicol, benzene ring, NO2, at para position CHOH, then CH, C double bond O. Okay, sorry, NH, C double bond O, CHCl2, and at carbon we are having CH2OH. So just keep on doing it, you will easily memorize them. Bactericidal. Bactericidal was basically POW. Okay, P for penicillin, A for aminoglycosides, O for ofloxacin. Bacteriostatic, that was ETC, erythromycin, tetracycline, and chloramphenicol. Okay, then we did antiseptic. Okay, so Dettol is basically made up of chloroxylenol and terpineol. Chloroxylenol, benzene ring, 2 methyl at meta to each other, Cl between them, and opposite to Cl was a OH. Terpineol, 6-member ring. Okay, the 1,4 position has methyl and a 3-degree alcohol with a double bond. Okay, then came with biothionyl. Biothionyl means there is a sulfur. Okay, 2 benzene ring. Okay, 2 benzene ring, because it is a OL, so there are 2 OH. Okay, just ortho to each other, and 2 Cls, one at ortho and one at meta to the OH. Okay, the similar is repeated over here. So next came is tranquilizers. Okay, so tranquilizers are class of chemical compound used for the treatment of stress and even mild mental diseases. They relieve anxiety, stress, irritability or excitement by inducing a sense of well-being. Okay, they form an essential component of sleeping pills. Now this is one which I think is little difficult to memorize because these compounds are little tricky to memorize. So mostly the derivatives of barbituric acid, that is veronal, okay, veronal, amytal, nembutal, luminal and seconal constitute an important class of tranquilizers. Okay, so we are talking about veronal, amytal, nembutal, luminal, okay, seconal. Now these are also known as barbiturates. So you should know that all the barbiturates or the derivatives of barbituric acids are hypnotic agent, they are sleep inducing pills. Okay, so some more examples are Valium and serotonin. Okay, so Valium and serotonin. Okay, so these are the structures. Now you have to like keep seeing the structure to memorize them. Okay, so till whatever we have done till now, okay, you should memorize those structure. Also artificial sweetening agents as well as analgesics that we have done. Okay, so we have to just remember the various tranquilizers. Okay, so that what you can do, you can just keep on reading every day, so you are able to memorize them. Okay, so the first was veronal. Okay, veronal. Okay, Valium, serotonin. Okay, veronal. Okay, so we are having veronal, Valium, serotonin. Okay, you cannot expect questions on their structures. Antibiotics, artificial sweetening agents, they are more important for these structures. Okay, then came iproniazid. Okay, iproniazid, okay, and phenelzyne. Okay, so these are the few examples. Okay, so you need to remember the name of these. Okay, so there is also equanil. Okay, so the first compound was veronal. Okay, veronal, Valium, serotonin, iproniazid, phenelzyne, okay, equanil, amytal, nembutal, luminal, seconal. Okay, so you need to remember this: amytal, nembutal, luminal, seconal. Okay, iproniazid, phenelzyne, equanil, okay, Valium and serotonin. Now this is difficult to remember. I consider this segment as the most difficult to remember. But if you are clear with the others, okay, if you remember the names of the other, then you can obviously eliminate and you will get the right answer. Okay. Okay, one thing which I wanted to tell you, which I forgot over here, aspharinamide is also known as salvarsan. Okay, so this is also known as, commercially it is known as salvarsan. This is used in the treatment of syphilis. So this is used in the treatment of syphilis. So aspharinamide is also known as salvarsan. Okay, so this is also known as salvarsan. It is used in treatment of syphilis. Okay, everything is taken out from NCERT. So don't worry about that. You can, if you are missing anything, you can just do the NCERT. Okay, now we'll quickly come to the next portion. Now that portion is little easy to memorize. Okay, next comes is the food preservatives. Now this is very easy. We add food preservatives to keep food for a longer time. Okay, this includes, if you look at the say pickle box, so it has lot of oil, it has lot of, okay, it has lot of oil, it has lot of sugar, it has lot of table salt. Okay, so the common examples of food preservatives is salt. Okay, if you forget, just remember the pickle box. It has salt, it has sugar, it has lot of vegetable oil, it has sodium benzoate. Okay, sodium benzoate is used in limited quantity and is metabolized in the body. Salts of sorbic acid and propanoic acid are also used as preservatives. Okay, so just look at the pickle: salt, sugar, okay, salt, sugar, sodium benzoate, okay, vegetable oils. Sodium benzoate should be in small amount because in the small amount it is metabolized. Sorbic acid and propanoic acids. Okay, salts of sorbic acid and propanoic acid. Antioxidants. Okay, antioxidants are basically added to prevent the oxidation of food. Example is BHT and BHA. BHT is butylated hydroxytoluene, okay, butylated hydroxytoluene, okay. So obviously you can understand it will have a hydroxy group, toluene group as well as a butyl group, okay. So BHT is butylated hydroxytoluene, BHA is butylated hydroxyanisole, okay. So this will have OH, OCH3 benzene, OCH3, OH and a butyl group, okay. So two antioxidants BHA and BHT. BHA is basically butylated hydroxyanisole, BHT is butylated hydroxytoluene, okay. So these are the two important antioxidants. Next comes is the soap, and I hope everyone knows about soap. Soap is basically the sodium or potassium salt of like fatty acids. Fatty acids are basically that contains more than, like they are having a large number of carbon in the chain. Okay, the common example is stearic acid, palmitic acid, oleic acid. If you look at this, this is basically a ester of glycerylic ester of stearic acid. Stearic acid has basically 18 carbon in it. Okay, so when you hydrolyze in basic medium, we have already done this in organic chemistry. Okay, so you will get the molecule of glycerol and you will get the C17H35 CONA. So this is basically the sodium salt of stearic acid, sodium stearate. So this is known as soap. Okay, so advantage of soap is a good cleansing agent and is 100% biodegradable. Again, very important point. Okay, theoretical question can be formed. It is biodegradable, that is microorganism present in sewage water can completely oxidize soap. Okay, therefore soaps do not have any pollution issues. Disadvantage of using soaps. Soaps cannot be used in hard water, okay, because hard water contains metal ion. Okay, hard water contains calcium and magnesium ion. So basically what happens, soap react with calcium and magnesium ion and they form a insoluble scum. Okay, so they react with calcium, so the anionic part RCO negative react with calcium and forms RCO2 calcium. Similarly, it reacts with magnesium ion and it forms RCO whole twice magnesium. So soaps cannot be used in hard water. Again, a very important point, because hard water contains metal like calcium, magnesium, which reacts with the anion of the soap and forms a white scum, okay, of precipitate of calcium and magnesium salts. Okay, now these are the types of soaps. Okay, this is directly taken from NCERT, so you can read them from NCERT as well. I am not going into detail. These are very basic theoretical things. Okay, the next portion was synthetic detergents. Okay, so I think someone has raised some doubt. So we'll cover the detergent part in the next lecture. Okay, this only detergent is left, so you can also cover it by your own. So just revise whatever we have done till now. Okay, so if you found that today you were able to memorize all the, okay, most of the structures that we did today, please write yes in the chat box so that it will help me in understanding whether you are able to memorize quickly with me or not, so that we can have more sessions like this where I will be just focusing you to memorize important things that are there in the JEE. So just write yes, okay, so that I will be able to understand that you are able to memorize them. Okay, waiting for your response. Just write yes, and I also open the session for Q&A. Okay, if you have any doubt, you can post your doubts over here. Okay, Shiva, you have asked this: a carbon atom with 4 different groups attached to it is considered a chiral atom. Similarly, can I consider a nitrogen atom with 4 different groups attached to it as chiral? Okay, so basically the concept of chirality is that it should not have a plane of symmetry. If to any atom, okay, if to any atom which can be tetravalent, which has the maximum covalency of 4, if 4 different groups are attached, if you consider carbon, you are attaching 4 different groups, you will never get any plane of symmetry, okay, or any center of symmetry, so that will always be optically active. But when you take a nitrogen, if nitrogen has a lone pair on it, okay, if nitrogen has a lone pair on it, so that will never be a chiral, because there is a phenomena known as pyramidal inversion that is happening over there. Okay, so nitrogen with a lone pair, any group attached to it will never be chiral, because there is a phenomena of inversion. The molecule will invert and will have two enantiomeric form of it, so overall it will be optically inactive. But whenever nitrogen is having 4 different group, when nitrogen attached to 4 different group, it will have a positive charge. Okay, if nitrogen is having 4 group attached to it, say R1, R2, R3, R4, then there would be a positive charge on it, so we'll say that it is chiral. Nitrogen with 4 groups, not a lone pair, 4 groups, different group, will have a positive charge on it and it will be optically active. But if a nitrogen is having a lone pair on it, okay, then it is always optically inactive. Only it will be optically active when that lone pair of nitrogen is present at a bridgehead position. Something like we did in penicillin, where nitrogen was in the fused, when the two rings was fusing, so nitrogen was at the fusion point. Okay, so that is known as the bridgehead position. So at bridgehead position, the lone pair won't be able to convert or won't be able to flip, won't be able to show nitrogen inversion. So a nitrogen with a lone pair is always optically inactive. Nitrogen having 4 different group with a positive charge on it will always be optically active. But when a nitrogen is there on a bridgehead position, okay, a bridgehead position means that where the two rings are fusing, then that will always be optically active if all the groups attached to nitrogen are different. Okay, similarly nitrogen in a 3-membered ring also, if different groups are attached to the nitrogen, then it is also optically active. Okay, so these are the small points that you should remember, because they directly come from the GOC portion. When we discuss after 23rd May, when we will complete the crash course, we will again revise few important topics. We will go into the questions answer segment, and we will come to all the other points. Okay, I hope I have answered to you correctly, Shiva. I hope you have understood what I was saying. So if you were able to understand, okay, and memorize things easily today, just write yes or something in the chat box, so that it reaches to me. These are live lectures, so whatever you will write, it will reach to me, just like the doubt that Shiva asked, so that if everything is positive, then I can decide and move with more such classes where I will be just focusing on how to memorize things and how easily we can do it. Okay, so I hope you enjoyed the session today. So this is Animesh signing off for now. We will catch tomorrow for again a very important session of inorganic chemistry that would be basically based on P block. Okay, thank you students.